Hello, scholars. Mr. Benzel here again. And today we're going to be kind of shifting gears into our next unit, which is on areas, surface areas, and volumes. So maybe in a past geometry course, or like when you were in grade school, you computed areas of individual shapes, but maybe you didn't quite get to like the 3D stuff and looked at like surface areas and volumes. So we're going to make sure today that you're really competent at area formulas and that you're able to piece together the area formulas so you can get an intuitive understanding of surface area and volume. All right, so first thing first, we're just going to kind of develop some basic formulas here. So the first formula you've probably seen before. So that's the formula of the triangle. So the area of a triangle is the area of it equals 1/2 base times height. So here's a triangle, and I'm just going to kind of draw a picture here. And notice that the H is not the diagonal line, but it is the kind of perpendicular line to the base. And this side here is what we call the base. And I did put a scale on the delta math where you're just going to really find that height and make sure that it is perpendicular. Because sometimes, you know, we look at the slanty thing and we call that the height instead, which is not the case. Another common formula that you're going to see in geometry are the circles, and we actually have the whole entire chapter coming up on circles. But I will be giving you a radius for the circle, and the area formula is pi r squared. And I always know that that is the area formula rather than 2 pi r, because our area, of course, is in square units. One formula that you haven't seen before is the trapezoid formula. So I'm going to call this B1, B2, and this is called the height. So the area formula for this is 1/2 times B1 plus B2 times the height. And we may have seen the 1/2 B1 plus B2 before. Think about for a minute where you've seen it before. Go back a few scales back to the trapezoid scale. It's from mid-segment. Mid-segment. So you can kind of think about this as the mid-segment times height. All right, and then the parallelogram, kind of similar to the rectangle formula, except we get really particular here with the height. It's not the slanty, it is the straight up and down perpendicular, and we'll call that side the base. So remember, your b, lowercase b, is base side for all of these formulas. Word to the wise. If you are looking at an area formula and you don't know what the letter stands for, make an effort to think about what that letter stands for, because that's going to help you identify the feature of the shape more easily. All right, so I'm going to kind of show you a common problem that you're going to see with trapezoids for the next one. Now, I like to give this problem on this lesson as bell work, or a problem like this. And I actually may give a little bit more information than what I am giving you on this problem right now. But I will tell you kind of the approach that some students do when they don't know the trapezoid formula. So maybe they interpret this as, you know, finding the area of the triangle and then finding the rectangle and then the area of the other triangle, and they kind of divide it into, you know, 3 pieces. So like 1, 2, 3. Now, a problem is that with the way that this problem is presented, we don't have that information, but fortunately we do have an area formula. So I have that the area is equal to half times B1 plus B2 times the height. And the 5 is the H. The 9 we'll call the B1, and then the 16 we'll call the B2. So we get half of 25 times 5. And then if you go to your calculator, you'll get 62.5. And we'll write units squared. So we do like you, especially when we get to like pen and paper work, to make sure that you are including your units, and that will also make your science teacher happy. So why are we doing area formulas? Well, it's not kind of an end, but we do use area formulas to kind of help us build a more intuitive understanding of surface area. So what I did here is I actually dug out a surface area problem. And I'm not going to give you a surface area formula right now, but what we're doing here is we're creating what's called a net drawing. So it's really just like a combined area problem. So what we did is we took this pyramid apart. So if you were to kind of unfold the pyramid, actually it's kind of like today, Alice was making 3D things out of paper. And if you were to kind of like unfold it into 2 dimensions, you'd have like a combined area problem. Now, if I'm doing a combined area problem, I think about, okay, how many of each type of shape do I have? And it turns out here that I got 4 triangles, and then I have a square, and that's equal to my area. And it is okay, like if you were in class showing me work, you know, this is actually showing me some understanding of surface area and how you're approaching this problem. All right, so I like to kind of think about the triangle here by itself. One thing that I would do, I know that this is a square, so I'm just going to mark all of that as like 6 point of it is 5, and then the height here is 6. So the triangle area is half base times height. So that's going to be, I'll just call this like the triangle area. So that's going to be half times 5 times 6. And when you enter that in your calculator, you get 15. And we'll just put units when we get to the end. And then the square area would just be 5 times 5, total of 25. And then I just put it back into my formula. So I have 4 times 15 for the area of a triangle, and then 1 times the area of a square. So I got 1 square on the bottom. And I get a total of 85. And since it's area, it's still in square units. Now, next class, we're actually going to learn a formula of how to do surface area so that you don't have to draw unraveled 3D picture every single time. Another type of problem that you may see on Delta Math, I'm just going to kind of give you a little preview here. I may have you solve for a variable on Delta Math. So like, let's say, and I'm just going to do one more problem here on the side. Let's say that I had a triangle, and I gave you that the area is equal to 30, and the base was equal to 5. We'll call this problem last example. And we need to find the height. So I would just write down the area formula first. So I have area equals to half base times height. So the area in total would be 30. And then I'm going to put in that base, 5. And then I need to find the h. One thing that I like to do to get rid of the half is to just multiply both sides by 2. And I'm going to kind of highlight that step in red. That 2 cancels with the 1/2. And as a result, you know, when we do that, we get 60 equals to 5h. Just divide by 2, or by 5. And when we divide by 5, I get that h is equal to 12. And maybe it would be, you know, 12 units. So be prepared for me to give you an area problem today where you are going to be computing an individual variable. So on Delta Math, we'll have areas of individual shapes like circles, triangles, trapezoids. And then I'm also going to give you a few net drawings, some pretty simple ones, because that's going to help build for literally build for next time for when we go into 3D and we learn about surface areas. So please stay tuned.